Thank you very much. I'm very excited to be here. This is actually I think it's my first remote meetup, so I'm really happy that there's a way to carry on knowledge sharing and meeting remotely from the comfort of our own home. So speaking of comfort of homes, just to give you a heads up, I actually live next to a main road, which is usually fine, but it's currently close to 6 p.m., which makes it peak traffic time. So, so I'm hoping for a quiet day for traffic, but if it gets a bit noisy, feel free to make a drinking game out of it. All right, so let's get stuck in. I'm going to talk about GraphQL with React Native, and specifically I'm going to talk about using URQL on the client side. So just quickly a little bit about me. My name's Kadi. I'm an engineering manager at Formidable. So here's a picture of me with slightly longer hair. So Formidable, if you've not heard of it, Formidable is a JavaScript consultancy. It's US and London-based. And we pretty much build things in JavaScript. So anything to do with JavaScript on the front end, back end. So we do React, Node.js, React Native, and we're really, really big on GraphQL and open source. So URQL, the library that I'm going to be talking quite a bit about today, is actually part of Formidable open source, which is why I know especially much about it. All right, so just to quickly go over the topics and what I'm going to be covering today. That's one. So I'm going to start with just talking about URQL and what is URQL all about. You've probably heard of it and maybe have some idea of what it is, but I'm going to explain how it fits into the GraphQL ecosystem. And then the following topics are kind of topics around URQL. So we're going to talk about exchanges, which is a way to extend URQL. We're going to talk about caching, the different opportunities there. We're going to talk about offline support, which is especially important when you're building mobile applications. Then we're going to talk about everyone's favorite topic, authentication. And then we're going to cover Devtools, so what kind of options we have for URQL. And finally, just a quick shout out to where the community is. All right, so let's start with where does URQL fit into the kind of GraphQL ecosystem. So say you're starting a new React or a React Native project, and the API that you will be using is in GraphQL. What you want to do then is you want a GraphQL client because you want some way to interact with the API that's kind of convenient. There are currently kind of three options in the community for this purpose. So we have Relay, we have Apollo client, and we have URQL. So Relay is kind of the first GraphQL client, so it's by Facebook. It's kind of an outlier compared to the other two. The API is quite different. And personally, I will admit I've never actually used it in production, although I've looked into it. So during this talk, I'm mostly going to be focusing on Apollo client and URQL. So what is URQL all about? Well, URQL, there's no way around it. It's kind of an alternative to Apollo client. So the history of it is it was first launched around 2 years ago, while Apollo client was almost the only GraphQL client. It was kind of the main go-to GraphQL client for everyone. And there wasn't really any like serious competition. And Apollo client at the time was having some problems. Well, not problems, but like some things that people weren't too happy about regarding the speed and the API. So then URQL was kind of built to be a really lightweight and fast, extensible GraphQL client specifically for React and React Native. And that's why it's kind of ended up being very similar to Apollo client because we kind of ended up with URQL kind of ended up taking the best parts of Apollo client and just extending them a little bit. And I think that's actually been really good for the community because any one client having a monopoly is kind of detrimental to improved user experience, but having more opportunities in the same space means that all the libraries separately have an incentive to improve. And also, like if you compare Apollo client to 2 years ago to now, I think both Apollo clients and URQL have kind of ended up influencing each other in a positive way. So I actually asked Phil, who's a core maintainer of URQL, for a quote for what URQL is. And he said, our place in the ecosystem was to challenge existing solutions and to be flexible enough to adopt new ideas. So it's all about flexibility and improvement. Now, before we get stuck in, I just wanted to briefly tell you about my experience using GraphQL, specifically with React Native. So the first time I used GraphQL, I think it was actually early 2017. And it was just a small project I did like a Lambda function with GraphQL. So that was like during the start of the GraphQL hype train. But the first real project that I did in GraphQL was in October 2017. So this was a whole application. It had like this fully fledged GraphQL API. It had the React Native app, and then it had a React frontend as well. So both of them were using GraphQL. And for the frontend at the time, we were using Apollo client. And like since then, I've had various projects in React Native with and without GraphQL. But when using GraphQL, I've always ended up using Apollo client because that was kind of the main thing, and that's what the clients wanted. And but this all changed later this year when I started a brand new greenfield project, and the client was very happy for us to use URQL. So that was my first actual production experience using URQL, which was very exciting. And yeah, I mean, I just wanted to kind of share my knowledge around how URQL compares to Apollo client, and kind of like the kind of up to like things around the URQL ecosystem that you can use. All right, so let's look at how you get started using URQL and Apollo. Well, so I've actually copy-pasted the Getting Started guide from both of the websites, just so you could compare them. And you can see that they are very, very similar. So if you already used Apollo, you can pretty much straight away understand how to use URQL. So if you look at Apollo first, what we do is we obviously install the client. Then we create the client using Apollo client, and we pass in two things, which is the minimum client. We pass the URL for the GraphQL endpoint, and then we also pass in the cache. So the cache is initialized, imported and initialized separately. And then we have an Apollo provider, which is also exported from the library. And we wrap our whole application in the Apollo provider and pass in the client. So going on the right to URQL, so let's look at how URQL does it. You'll see that it's very similar. So we create the client. One thing that's different is that you don't have to pass in a cache yourself. So URQL does come with a cache. It comes with document cache by default, but you don't need to pass it in. So the minimum client only has one variable, which is one parameter, which is the URL. And then the rest of it is pretty much the same. We have a provider, we wrap our whole application in the provider, and we pass the client into the provider, so it will be accessible within the application tree. All right, let's look at how we query data. So going with Apollo again, so we would use a hook. So hooks are the cool new way to, well, not new anymore, but it is the go-to way to do side effects and handle state in function components in React and React Native. So we have a use query hook, which is exported from Apollo client, and we pass into it a GraphQL query string, but which needs to be wrapped in the GraphQL template tag. So the tag converts the string into the GraphQL AST. So we pass that in, and what we get as a return, we get an object that has all the metadata for the request that's currently in flight. So we have whether it's loading, if it's errored, and once we get the data, we get the data. So going on the right again for URQL. So one thing you'll notice that's different is we don't need to wrap the query in the GraphQL tag. That's actually done within the library. So all we need to do is pass in the template string. The API is a little bit different in that we pass in an object with a query key rather than like a top-level argument, but the idea is the same. And the other thing that's different is rather than returning an object, it actually returns an array, and response in this case is an object that has fetching, error, and the actual data. And this is done because, I'm not showing it here, but the second array item in that array is actually a function that allows you to refetch that query. All right, let's talk about exchanges. So exchanges are a very, very central concept in URQL. They are a series of operations that transform the input stream to the output stream. This is like the documentation description. But basically what it is, like if you think about what a GraphQL client is you have a request, you say, I want this data, and then like things can happen to this request until we actually fetch the data. The data comes back and we give it to the client. And then during this kind of data flow, we can still interact with the data. And this is what an exchange is. If you were to compare it to something in the Apollo world, they're actually quite similar to Apollo Link. But they go a little bit further than that because in URQL, literally everything's an exchange. In fact, so Yovi, who's also a core maintainer of URQL, so I asked him for a quote about URQL, and he went with that URQL is so extensible that even the cache is an exchange, which kind of goes to show just how central a concept exchanges are. So how do they work? Basically, so I have some pipes here, and these are going to demonstrate the kind of out-of-the-box exchanges that you get with URQL. So when you just instantiate the client just with the URL, you get 3 exchanges that are already applied. And this is what we're going to look into. So on the left, we have use query. So this is the hook that we've called. Now, this is going through all these 3 exchanges, and we get data at the end. All right, let's look at each of them. So the last one that we have, so this is always the last exchange in the exchanges array, is called fetch exchange. And what this does, it pretty much does the heavy lifting of the actual data fetching. So it takes the query that you've given it, that you requested, uses the fetch API to fetch it from your GraphQL API, and then adds the results to the output stream, and then they get sent as the query result. On the other end, the other exchange that we have is called dedupe exchange. And what this does is it removes the duplicates from pending operations. So for example, in React, this will happen quite frequently. If you have a React render tree, you have several use queries and they query the same, exactly the same query. Then you're going to end up with multiple pending queries that do the same API request, which is redundant. So what this does, it removes the duplicate queries. But once data returns, then both of the use queries will get the result. And finally, we have a cache exchange. So this is the default caching logic that comes by default. It's called document caching. It's quite a lightweight, simple cache. Now, if you're kind of following along, you might find the arrows a little bit confusing, because if you think about how a cache exchange works, is it has 2 jobs, doesn't it? Firstly, it needs to check, is this thing in the cache? And if it is, just return it, if that's what's desired. And secondly, it needs to also save the results in the cache after they've been returned. So how can it be in the middle after the fetch exchange? Well, in order to explain that, I actually need to do a little update on how the actual data flow works in exchanges. So this is a more accurate representation of how the data works, a data flow works. So from a use query, we go into the dedupe exchange. So this is the actual raw query that, the GraphQL string. We go into the dedupe exchange. Dedupe exchange looks at whether this query already exists and removes it if it doesn't. Then we go to the cache exchange, which does this thing. Then we go to the fetch exchange. So now this does the actual heavy lifting, does the API request. This is why this exchange always has to be at the very end. Now this comes back, and then instead of returning the data straight to the front end, what it actually does is it goes back through the cache exchange, and then through the dedupe exchange, and then finally out the other end. So every exchange has 2 opportunities to update the data, once when it's the query and once when it's the result. So this is like a bit unusual. It might take a little bit of time to wrap your head around it. But if you if you figured it out, you can write your own custom exchanges. So you can modify any of this. You can remove any of the exchanges. You can replace them, and you can put your own custom exchanges at any point in this exchanges array, as long as they follow the API. And now you might wonder, how does this magical API work? Like, how do you have an exchange that can update the data in two places? Well, it's all doing like using streams. So this is an example of a custom exchange that's a no-op exchange. So this means that the data passes through it, but the data isn't being modified. So if you see, I look at the bottom, we have the exchanges array, and we have the dedupe exchange, the no-op exchange, and then the fetch exchange. So if you look at what this does, so we get the client and we get the forward function, right? And then the operations here, the forward operations. So these are before they've been fetched. So this is the query that the user has. So in this exchange, I could update these operations. I could add some headers, or I could move operations. And if I want to, so I can also not forward it if I don't want to. But if I want to pass it on to the next exchange, so in this instance, if I want to pass it forward to the fetch exchange, I call forward with the operations. And the operation result is what comes back after the fetch has been done. So this is the actual result that came from the API. And if I want to, I would be able to update this result as well. And finally, we return the operation result, and then this gets passed into a dedupe exchange. So it can be a little bit much when you get started, but actually once it clicks, it's very satisfying. All right, so why might you want to implement your own exchange? Well, one of the common things is authentication. And if you're anything like me, implementing authentication, you have this like scared, oh no, please not me look, because it's always a hassle. So in my last project, when I used URQL, I built a custom exchange to handle authentication. So we had authentication logic where we need to fetch the token from async storage. We need to add it to the headers. We need to like check if there's been an auth error, and then we need to trigger the refresh logic. So it was quite complicated. And I found that authentication has always been complicated. It's never been easy. It's never like just worked, regardless of how many times you've done it. When I used the Apollo client, I also found it quite difficult to do it. And I found it quite frustrating that no clients kind of come with authentication built in. And, why not? And indeed, why not? So as of I think 2 or 3 weeks ago, URQL has built-in support for authentication. So we published an auth exchange, and basically it's a really flexible API that follows the kind of usual JWT-based authentication. So it allows you to retrieve auth state from storage. So it can be async storage in case of React Native, or just local storage in case of the web. You can add auth headers, or just however you need to add the auth state into your outgoing requests. And also has built-in support for token refresh. So if your token refresh is in a mutation, or if it's a separate fetch endpoint, we can support both. And you can also track and forward auth errors. And not only that, there's also a fully fledged, very detailed authentication guide if you go to the URQL documentation, and it explains kind of the common authentication flow, and it has a step-by-step instruction of how you can go about using the auth exchange to add authentication to your application. So this is, I think it's one of a kind, or it's definitely a very needed addition, because I found that everyone tends to struggle with authentication. So hopefully this makes it a little bit easier. All right, let's talk about caching. Well, caching enables you to basically fetch recurring data from the cache instead of querying anew each time. This saves on network requests. It makes the experience faster. Well, I'm sure I don't need to sell anyone on caching. As I said, by default, URQL uses the document cache, which is a good cache, which is good for simple applications. So the way you interact with the cache is basically on a per query basis. So per query, you can optionally pass in a request policy key, which will determine whether the data gets fetched from the cache or not. So the options here are cache first, cache network, cache only, and network only. So cache first is the is their default request policy, and what this means that it will, when you do the query, it will look in the cache to see if this exists already. If it does, just return it and don't do a network request. If it doesn't, do a network request. The other options are cache and network. This is quite a nice one because basically what this one does is if there is a request already in the cache, it returns it, but it also does a network request so that if data has changed, it will get updated in the cache and then the UI gets updated. So the user will always have something to see. And then we have cache only and network only, which are probably self-evident. Now you might immediately think, okay, but how do I invalidate the cache? Well, as with everything in URQL, it's an exchange. So there is a request policy exchange, and what this does is you can set the amount of time that you want the request to be valid. So in this case, it's 1 minute. And you can also optionally pass in a should upgrade function. So after a request is more than 1 minute old, in this case, it will check whether the request policy was cache only, and if it wasn't, it will do a fresh fetch. All right, Graph Cache. So I mentioned before that document cache, which is the default cache for URQL, is quite basic and it doesn't handle interdependencies. So there is an alternative cache which is much more clever, and it's called Graph Cache. And in order to add it to your exchanges, you install it at URQL Exchange Graph Cache, and you initialize it in the exchanges array instead of the document cache. So one of the handy things that this does is it handles cache updates after a mutation. So here in this example, we have a list of to-dos. So on the first code example here, we've got our use query, we've queried our list of to-dos. So this is somewhere else in the application, and if you're using a cache, this automatically gets added to the cache. Now, somewhere else in the application, we have this update to-do mutation where we can update the to-do item title based on the ID. Now, the question is, after we've done this update mutation, how does the cache get updated? Well, there are a few options. So if you used Apollo client, you'll probably remember refetch queries. So they are an array of queries, query names that get refetched automatically after a mutation has occurred. So this works, but it does create quite a few additional network requests that arguably aren't necessary. And also, we already have the data, so it seems redundant to do yet another network request for it. Then the other option is to manually update the cache with the mutation results. This is another thing that you used to have to do with Apollo. So you literally created an update function so that after each mutation you have to apply this, which got very verbose very quickly. But actually, what we can do, because we're using GraphQL and it's all typed, we just let the cache handle it. So with Graph Cache, the cache is automatically updated with the mutation result. And the way it's done is every piece of data has a type name. So this is internal. You don't need to query it explicitly. And it needs to have an ID, which you do need to query explicitly. So what Graph Cache does is it matches the specific piece of data based on the type name and the ID, and then it updates all the fields. So the only thing you need to do is remember to, after the mutation, re-query the thing that got updated. You might run into a problem that I ran into, which is that the data doesn't have a reliable ID. Well, in this case, you can add it manually in the cache config. So for example, here you get the parent element, and you can calculate the ID based on the parent if that's possible. But if it's not possible, you can also simply opt out of the cache for these values. So yeah, that can work as well. All right, and what if the mutation result doesn't return everything that gets updated? So I ran into that quite a few times. Well, not quite a few times, a few times, where basically the mutation can only return one thing, but sometimes in your API you change one thing, but something else also changes. So in my case, it was something on the user profile that changes when you update a completely different entity, and this entity gets updated in the cache, but the user profile doesn't. So basically what I can do here is when this particular mutation has finished running, I can take the mutation result and do whatever I want in the cache to actually update it. All right, offline support. I won't go very deeply into it right now, just because I don't have that much time. But GraphCache is set to support offline mode. So it's currently in, I think, alpha or beta. So it's kind of early days for it. But it's built to have kind of a flexible API where you can save and retrieve the data when you start the application, when you close it, and also I think there'll be some method of replaying the mutations. All right. Devtools. Well, every good library needs some devtools. So URQL has their own devtools, which is quite handy. So you can use, if you're on the web, you can use the Chrome extension or the Firefox extension. But if you're on React Native, there is an Electron app, which you can launch just from the terminal. So I'm just going to show you a little bit of what it looks like. So in order to set up, surprise, surprise, it's an exchange. So the way you set it up is you install URQL DevTools, and then you add the DevTools exchange as the first exchange in your exchanges array. You don't need to even worry about it being available in production, because it automatically doesn't launch when your node is production. And then if you're in React Native, you just go on your terminal and do npx URQL DevTools, and you will download and open the Electron app. Or if you're on the web, you just open the Chrome or Firefox extension. All right, and this is what it looks like. So this is the Electron version, but the DevTools look very, very similar. So we have 3 tabs. On the first tab, we have the Schema Explorer. So the bit on the left, this is kind of all the data that's currently in the application. So this populates itself as you kind of navigate around your screens. So on the right, we have details on the currently selected data. Then in the Events tab, this is kind of similar to the Network tab in Chrome. So you can see all the queries and mutations that your application has done. And you can see how long they look. You can inspect different kind of internal events. And then on the right, you have all the metadata about the query and the response. And then finally, we have the Request tab. So the Request tab is quite similar to GraphQL, like the GraphQL Playground, with the difference that this in itself gets run through the exchanges. So in my case, for example, I have an authentication header that needs to be added to each request. So I don't need to add it here separately as you would in GraphQL Playground, because this gets run through all my exchanges. So it's as if my application did the request, which is quite neat. All right, and lastly, around community. So excitingly, URQL community has historically been in Spectrum, but as of recently, it's moved to the discussion tabs in GitHub discussions, which is awesome. So if you have any questions, or you want to get started, or you don't know what to do, or something isn't working, rather than creating an issue, you can actually add a discussion and start something there. So it's pretty active. You'll definitely get a response. All right, well, that's pretty much it. That was my kind of drive-by explanation of what URQL is and how it works. So I've got some links here, and check it out. And if you have any questions, you can ask me directly on Twitter, or post in the URQL discussions tab on GitHub. Thank you very much.